All right, question number 2, determine the intervals of the domain over which the function is continuous. And this is similar to question number 1. And we talked about, in question number 1, continuity and what it means for a graph to be continuous. And in order for a graph to be continuous, we know that we have to be able to draw the graph without lifting up our pencil from the paper. If we have to lift up our pencil from the paper, the graph is not continuous and therefore has discontinuities somewhere along the way. Let's see what we have here with question number 2. Well, again, just like number 1, we have a line in the form y equals mx plus b, and the equation here of this line is not so much important. All we're looking for is the domain intervals where this line exists. And we know from class that all lines of the form y equals mx plus b, their domains are from negative infinity to positive infinity. And we would expect this line to have the same domain, wouldn't we? Except, look down here at the bottom of our graph, they've called a specific point out to us. They've called out the point -2, -7. And this point that they've called out to us is an open circle. This point that they've graphed for us is an open circle, and we know that when graphing, open circles are important. Open circles mean discontinuities. It means the graph of this line does not exist at this point, -2, -7. So because there's a discontinuity right here, the graph doesn't exist, we can't say the domain is from negative infinity to positive infinity because that's not true. The graph doesn't exist right here. And because we're talking about domain, right, this is a domain interval, well, we're going to have to adjust this negative infinity to positive infinity to take into account the fact that our line doesn't exist when the x value is -2. So let's go ahead and erase this domain interval, and let's start again and take this point into account. Well, again, we know that because this is a line of the form y equals mx plus b, it is going to exist from negative infinity, which would be down here somewhere, right? If we continued this line down to the left, way down there would be negative infinity. And as we come up, as we're coming up from left to right, the x values are getting bigger, getting bigger, getting bigger, until they get to x equals -2. And they don't exist here at -2. So they come from negative infinity to -2, and they stop. They don't exist at -2, and so we close this part of the interval with a parentheses, right? Because we're saying go from negative infinity up to -2, but don't include -2. So we use parentheses, and then we're going to use our union symbol, because at -2, we're going to jump over that point, put our pencil back down, and continue graphing the rest of the way. So we're going to pick back up again at -2, and from there we're going to continue to go out to positive infinity, which is all the way, way off the graph, right? Never stops. This line is continuous at infinity. So from -2 all the way out to positive infinity. And so there's the interval of the domain over which this particular function is continuous. So the x value for this line exists at every x value between negative infinity and positive infinity, except for the one x value here at -2.